Assalamu alaikum and good morning. My name is Muntasir Awad from Section 2, Group 8. My teammate Fatullah Muhammad and Muhammad Noor Fizari. Okay, the title of our project, the BID Control Design System for Speed Control System. Okay, now I will present the introduction. Okay, control system design has become much more important in recent years, which has led to a large increase in industry environment. Today, there are control devices for many company operations and aspects in such system, electric machines, as well as the research of their stability and control play a significant role because the processing usually use DC motor to run their duties. These engines have very straightforward construction and operation models. Okay, there are numerous ways to regulate the DC motor, including P and PI and PID, and position controller. Simple implementation of this as possible using analog electronics. This paper goals is to present a system theory-based DC motor, speed control, and strategies the proprietary integral design. Okay, this for all.
Hello, my name is Fathullah Muhammad Fathullah Al-Gamudi. I am from section 1, group 8. So I am gonna to present my part, which lecture review summary. So here for DC concept, a wide range of speed or position control is necessary for a robotic and actual application. The basic property of a DC motor is that speed of the DC motor can be adjusted by varying its terminal voltage because of its simplicity and how cost and the DC motor is used extensively in research, industry and laboratory activities. Thus, a more precise and faster control system are required, as well as improve performance. So for PID characters, there will be three approaches to dealing with the error, and use the proportional term to handle the present, and three using the integral term to recover from the past, and use the derived term to forecast the future. For characters of PIT, so PP, this controller has effect of reducing rise time, steady state error SE, but the percentage of overshot OS in the system is high. So number two, HTI also decrease the rise time T, but it will eliminate the SSE of the system, even through it eliminate the error, but the percentage of OS is increased, and it will affect the setting time as well. So for the last one, KT, this controller will take action to improve the transit specification and stability of the system. So for previous studies of PID controller on DC motor, research of speed control of DC motor using fuzzy logic control conducted by Limited for reference and number two in optical tuning of a fractional order PID controller for DC motor speed control via the choke atom search optimization algorithm. So the last one in design and research of DC motor speed control system based on the improved BAS.
Okay, problem statement. How to design the BID control system for controller this the speed of plate with the motor DC as an actuator. Okay. Secondly, how to determine the BID gain of the system. Third point is it manual and automatic tuning of the BID controller look have the same result. The objective of this project to resolve the motor speed control system using the theory, method, and idea covered in class lecture. Then additionally for this project, student had to use a suitable piece of software such as MATLAB to simulate the motor speed control system. And last but not least, students will be applied to understand the distinctions between and significance of classical and modern control system in current technology for the objective of sustainably development during the course of this project. Okay, the methodology to execute our problem. We provide a methodology in flowchart from start with establish project goals and continue until we get the electrical system to control the speed of DC motor using PID controller. In project instruction, there are a list of parameters that we must follow to get the results. After results collected, a discussion will be held among the members. Okay, this is a flowchart. Okay, of methodology control goal to control the speed of the plate with motor design. Firstly, establish the control goals and identify the variable to be controlled. Then write the specific okay, and then establish the system configuration and obtain a model of the process, and then describe a controller and select key parameter to be adjusted. Okay, and then optimize the parameter and analyze the performance. Okay, and if this performance meet the specify, then we will do design. Okay.
So here for part mathematical modeling of DC motor. So the figure show us the equivalent circuit of DC motor and the equation which VAT equal to I R plus LADI divided by DT, which VA is armature voltage and A is armature current and RA is armature resistance, LA is armature inductance, EA is back EM voltage. So here by substitute E equal KP omega T to equation I, so the electrical part will be which if E T equally IA RA plus LA divided by DIM for DT plus kb omega t. So for normal operation, the development torque must be equal to the load torque plus to fraction and the interior. So here, which where gm is a moment of the interior of the motor, and bm is the motor fraction constant, and gl is the moment of interior of L load, and PL is friction fraction of a plate, and yes, then Tm equally G T divided by d omega divided by t dt plus b t omega of t by Tm, which is a motor torque, and Gt is a total moment of interior, and omega t is another speed. Bt is total fraction. So here substitute Tm equation, so the mathematical part will be k a I r, which gt d omega divided by dt plus bt.
Okay, for a combination between DC motor and PID controller. Okay, after we combine by two item, we have a controller and DC motor. So we must do to use the closed loop system, which is constants of unity feedback, and beside that, I have the parameter used. Okay, that's all.
Hello and Assalamualaikum. I am Muhammad Nofazari bin Adnan and my matrix number is AE190060. So I will explain about the simulation and result and discussion. So this is the equation that we got after we solving the circuit. This is the transfer function. So Ka is the motor torque constant, and Kb is electromotive constant, and R is resistance, and Ls is inductance, Js is moment of inertia, and B is viscous friction. So this is the block diagram that we use in our MATLAB to obtain the result and to run the simulation. So now I explain about the parameter of this motor transfer function. So this is the component in the circuit that we use. We got the rated motor terminal voltage, which is 24 volt, the moment of inertia of the rotor, moment of inertia of load, motor viscous friction constant, viscous friction of plate, and total moment of inertia, total viscous friction, the electromotive force constant, which is 1.25 volt radian per second, and a motor torque constant, and electric resistance, and electric inductance, and lastly the rated motor speed, which is 1500 rpm. So we implement the system in MATLAB Simulink, and we use this circuit in our Simulink to do the simulation. So this is the open loop circuit of the DC motor, and the closed loop system with the PID controller. We just add the PID here to do the simulation. So the result and discussion, the performance of the open loop DC motor, you can see here that the input speed is 900 rpm. As they gone through this electrical part, the motor torque constant, and mechanical part, the output seems to be 699.7. And the next one is the input speed is 1000 and 1500. So the output speed is 1166. So the open loop block diagram for the DC motor is with respectively input speed of 900 rpm and 1500 rpm. The both output speed are obviously drop compared to the input speed, so it did not reach the desired input speed. So as you can see, this is the response graph with input speed of 1500 rpm. So as you can see, it did not reach until 105,000. It only reached something between 1000 and 1200 rpm, so it did not reach the input speed. So as of that, we use the PID controller for the DC motor to get the output speed that we want from the input speed. So to reach the same amount of input speed when we run the simulation. So this circuit is basically closed loop after we add the PID controller. We use three possible combination, which use the P, PI, and PID. So for the P, the KP is 250. For PI, the KP is 15, and TI 1.5, and KI is 10, and PID is 50. TI is 1.11, KI is 45, TD is 0.06, and KD is 3. So this value we input into the simulation into the PID controller to get the result, and we show it into a graph. So this is the graph that we obtain after we run the value in the table before. So for the input speed of 900 rpm, the P controller with the value of KP is 250. We can see the graph have a steady state error and then come back to the constant 900 rpm. So the big quantity of KP is used to increase the output speed as much as possible in order to obtain the required speed. So after we adding PI controller, the value of KP may be gradually lowered using the integral controller, since the integral will minimize the steady state error to obtain the desired output, where KP is 15 and KI is 10 for the PI controller. So the last but not least, the PID controller, by adding another integral controller, which is KP equal to 50 and KI 45 and KD to 3, we may extend the response rising and settling times. So the DC motor become steady and stable. So the graph that we obtain from the input speed of 900 rpm seems to be the same as we use the same controller, which is P controller for the 1500 rpm. The value of the rpm overshot a little and then become constant. Same with input speed for 900 rpm using the P controller. So for the PI controller, the value slowly and steady went up and become a constant, while using the PID controller for 1500 rpm, it has overshoot a little and become constant. We try to differentiate between the manual and versus automatic PID controller tuning to see if which is more precise in calculating the result. So for the PID tuning, in the manual we use KP 550 and the KI is 45 while KD is 3. So for the automatic, we obtain the KP is 19.76, KI is 19.58, and KD is 0.6. So this is the result that we compare after we input the value on the table just now, and the comparison of response DC motor with PID controller using the manual tuning and automatic tuning. So in the graph we can see that the black one is the manual tuning and the pink one is the automatic tuning, and the black one overshoot more than the pink one, which is automatic. So we can see that automatic tuning is the best if we want to bring a more precise result. So we will compare between the open loop and closed loop in the DC motor. So the bottom one is the open loop and the closed one is here, which is we use the PID controller. So the open loop did not even reach the input speed, which is 1500 rpm, while the closed loop overshoot a little. So this is the comparison between manual, automatic, and open loop result. So for the overshoot, we obtain the manual is 4.53 and automatic is 2.07, while open loop did not reach the input speed at all. So for the rise time, it for the manual it need 0.189 second for it to rise until the maximum input speed. For the automatic 0.2 second, for the open loop 3.581 second. So for the peak time, the manual is 1.579 second, automatic is 1.17 second, and open loop is 10 second. For the settling time, manual is 1.243 second, automatic is 1.297 second, open loop is 5.817 second. So for the steady state error, for the manual is 0, automatic is 0, and open loop is 334. I think that's all for the result and discussion and the simulation. Thank you.
For conclusion, in this project, we conclude the study highlights the importance of PIT controller parameter and how to perform the same for a closed loop system using a mathematical simulation tool. The PIT controller was added into the DC motor to control the speed of the blade. Some changes to the algorithm are required in order to speed up the search process and ensure the optimal result. Therefore, the solution was discovered.